If you stick your head out the window right now and look at the sky, the chances of seeing them are really high. The incredibly long, white cloud lines left behind by massive commercial jets in the blue void. While for some people this is just a simple sky scenery, for others, these lines are at the center of a never-ending debate that has been going on for years. If you do a quick search on the internet, you will come across countless conspiracy theories claiming that these white trails are actually chemicals intentionally released into the air. They call them chemtrails. A system where governments or secret organizations poison the air, control the climate, or manipulate people. But the truth is, decisions in aviation are not made by the fantasies of secret organizations, but by the ruthless rules of thermodynamics. Planes are quite different from land vehicles so that hundreds of people can stay in the sky for dozens of hours. We previously explained how a clever system was built even for toilet waste, which seems like a simple task. Aviation technology is obliged to produce innovative solutions to challenges. Otherwise, a plane could not even move on its wheels on the runway. Contrary to conspiracy theories, those trails left behind by planes are not a chemical weapon. They are the inevitable byproduct of one of the greatest engineering achievements in aviation history, contrails. That is, condensation trails. And do you know what the truly ironic thing is? The real science behind these trails is much more interesting than those conspiracy theories, and much more dangerous for our planet. To understand it, we need to descend into the heart of a relentlessly working monster, 35,000 feet up in the sky, exactly where that white line begins. When we look at a jet engine, we usually see a massive fan. We think that air passes through this engine like a vacuum cleaner, and in the meantime, it pushes the air backward, carrying the plane forward. Actually, your thought is fundamentally correct. However, this working principle has different consequences as well. A modern jet engine is actually a massive chemistry laboratory. Planes use a highly refined fuel called aviation kerosene to operate. When this fuel, consisting of carbon and hydrogen atoms, meets the oxygen taken from the outside in the combustion chamber of the engine, it releases a massive amount of energy. Maybe we will explain the working principle of jet engines in another video. When the engine starts spinning at top speed, an immutable rule of chemistry comes into play: the mass that enters must equal the mass that exits. When oxygen and hydrocarbons burn, they do not just produce thrust. At the same time, carbon dioxide, various gases, and something most people wouldn't guess are produced: water. Yes, you heard that right. A jet plane, just like a giant flying pot, sprays kilograms of water vapor per second into the atmosphere. If planes flew very close to us or traveled like a land vehicle, nothing would be visible except the vapor layer coming out from behind. This vapor is exactly like the hot vapor coming out of car exhausts in cold weather. Everyone has seen this. But planes don't fly on the ground, and they have engines quite a bit larger than a car's. If you liked our videos where we explain the working principles of planes and the world's largest machines with simple 3D models, don't forget to subscribe. At an altitude of 35,000 feet, the atmosphere is a completely different place from the Earth's surface. Here, the pressure is less than a quarter of sea level, and the temperature is around -50 degrees Celsius. Now let's run the engine we just mentioned at this altitude. The temperature of the water vapor coming out of the engine is approximately 600 degrees Celsius. This boiling hot, invisible water vapor collides with a freezing air current of -50 degrees in a tiny fraction of a second. That is the moment the magic happens. The water vapor loses heat so quickly that it turns directly into ice crystals without even having the time to transition into a liquid form. It transforms, but this does not happen in a simple way as you might guess. For water to freeze in the air, it needs something to cling to. In completely clean air, water struggles to freeze. And right at this point, another byproduct produced by the jet engine takes the stage: soot and ash particles too small to be seen by the eye. These soot particles shooting out of the engine's exhaust act as perfect condensation nuclei for the water vapor. Water molecules instantly stick to these soot particles and freeze. Billions of soot particles turn into billions of ice crystals. And that white trail in the sky, meaning the contrail, is formed. You can drop the conspiracy theories now. Or, you can explain this to people wondering about it in a social setting. But wait a minute. You might have noticed that sometimes a plane flies in the sky without leaving any trail, sometimes the trails melt and disappear within a few seconds, and sometimes they stretch from horizon to horizon and stay in the sky for hours. Why is there this difference? The reason for this difference has little to do with the plane. The answer is not about the plane, but about what the air the plane is flying through is like. As you can understand from natural phenomena, the air has various different phases. Sometimes the plane travels through a layer of air saturated with moisture, while sometimes it has to travel in bone-dry air. These different states of the air affect its moisture holding capacity. If the plane is passing through a dry air mass, the formed ice crystals are instantly absorbed by the dry air and vanish by sublimating. The line fades away within a few seconds. However, if the atmosphere is already saturated with moisture at that altitude, the ice crystals have nowhere to go. In fact, the existing moisture in the air clings onto those ice crystals left by the plane, making them even larger. That incredibly thin line slowly expands, spreads, and turns into a massive, artificial cirrus cloud called Contrail cirrus. We now know that the trails behind the planes are frozen water vapor. But what if I told you that for our world, these cute clouds are more harmful than the carbon dioxide produced by the engines? While everyone says that the carbon dioxide produced by jet engines and the fuel released into the atmosphere harm the environment, scientists have encountered a much more disturbing reality. The planet-warming effect of those beautiful, white clouds planes leave behind could be greater than the effect of all the carbon dioxide emitted since the beginning of aviation history. Yes, ice particles are warming our world. The structure of natural clouds is generally thick and low. To protect our world, this structure cools the Earth by reflecting the sun's rays back into space during the day. However, contrails are extremely thin ice clouds formed very high up in the atmosphere. They allow short wavelength radiation from the sun to reach the Earth's surface. But when night falls, they trap the long wavelength heat energy that the Earth tries to radiate back into space, just like a blanket. In physics, this is called radiative forcing. Especially in regions with heavy air traffic like North America and Europe, the sky is covered with these artificial clouds created by thousands of planes. Like an invisible greenhouse, they prevent the heat from escaping into space. These tiny ice crystals are significantly increasing global warming. If these trails are one of the biggest hidden actors of the climate crisis, how can we solve this without giving up flying? Do we have to reinvent the engines? Actually, there is no need for such a difficult task. Just thinking simply is enough. As we mentioned before, the atmosphere varies everywhere and in every layer. Therefore, it is enough for us to fly the planes in the right place. Air masses that have reached ice supersaturation, meaning they are highly prone to creating contrails, are generally in very thin layers. Aviation data shows that only 2% of the flights in the world cause 80% of the persistent trails in the sky. So, if we shift a plane's route just 2,000 feet up or down, we can completely avoid that humid region and ensure it flies without leaving any trail. Today, airlines and tech giants are using massive artificial intelligence models. By combining satellite data and deep learning algorithms, they send instant route updates to pilots to avoid contrail-forming regions, just as if they were evading a storm. Just by altering our altitude by a small amount, we have the chance to cut aviation's impact on the climate in half within months. Never in aviation history has a problem had such a simple, cheap, and fast solution. As we said, the sky always demands us to think differently. Sometimes a problem can be solved by vacuuming toilet waste using a pressure difference, and sometimes we can save our world by changing our route just a little bit. By the way, how do you solve your problems?